Okay, am I sharing my screen right now?
Yes, madam.
Ya,
Okay,
madam.
now. Okay, okay, ada suara keliling ke? Sorry if bising sebab I punya headphone rosak, so I terpaksa pakai without headphone But you can hear me very clear?
Clear, madam.
Okay, all right. So welcome to Dynamics Topic 1, Kinematics of Particles. Okay, my name is Dr. Yasmin Sahul Hamid. So for today's class, we're going to go through topic 1, which is on kinematics of particles. Okay, as you can see here, the picture on the left is a picture of a motorboat. Okay, so there are a number of motorboats in the picture. So even though the motorboats are considered something very big, very large, huge, we can analyze the motion and assume it as a particle. Okay, and the motion of a car that you can see here, we can also analyze. So basically, we can describe what is the position, what is the velocity, and what is the acceleration. So basically, what I'm trying to say is the picture that you see here, we can assume the object is a particle and we can analyze the motion. Okay, right. Now, so in engineering mechanics is the study of how rigid or non-deformable bodies react to a force acting on them. So do you understand what does rigid or non-deformable bodies mean? Anyone would like to say? Would like to try? Not sure. Okay, it's okay. Non-deformable bodies means it does not change shape. It is fixed with that shape. Okay, all right. So we study things that does not change shape, that are rigid and not deformable. For example, this box of pencil color pens, a cup, a book, a ball, an aeroplane, a vehicle. Basically, they don't deform and change shapes. It's not like the slime, slime that kids likes to play, kinetic sand. It can change into different shapes. No, we consider something that is rigid and non-deformable, and we study the forces that are acting on them. Okay, so that is what is in engineering mechanics. Okay, so in engineering mechanics, previously you have learned about statics. So you all are the survival of subject statics. That's why you are now taking dynamics. Okay, so basically, statics is the study that focus on the body that is in rest or moving at constant speed. So previously, when you study static, you look at things that is on a rest mode. Rest mode means not moving, or it is moving but at constant speed. The speed is constant, but in the same direction. But when you go to dynamics, you can assume that it may not be rest. It will be rest. It can have also constant speed, but it can also accelerate, it decelerate, pecut, something like that. The speed can change throughout, and it doesn't mean necessary it will be in the same direction. It can move to the left, right, up, down. That is dynamics. Okay. And in static, previously you used Newton's first law. And what is Newton's first law? Newton's first law is the resultant force acting on a body equals to zero. Okay, but now you're in my class and we are going to learn about dynamics. And when we learn about dynamics, we study the motion. What is the motion involved? Okay, we want to know the motion of the particle. We want to study that motion. So in dynamics, we have also kinematics. So this kinematic is what we're going to learn today in topic chapter 1. Kinetics is in topic chapter 2. Okay, as I mentioned in the previous class, for you to do well in subject dynamics, you must be able to differentiate what is kinematics and kinetics. Okay, because the method in solving the problem is different. And how do you decide whether to use kinematics or kinetics is based on the question given. What is the variables given and what are the constant given, and from there you can decide. Okay, now, so what is kinematics? Okay, kinematics is concerned with the geometric aspect of the motion. When you talk about the geometric, you're talking about displacement, velocity, and acceleration. These are the geometric aspect, and also time. Okay, so basically kinematics does not study motion that is caused by force, so it has no force involved, no force. So when you are given a question, if it has force, it means it is not kinematics. Obviously it means it is kinetics, because the study of kinetics is the relation between the force acting on the body and the mass of the body and the motion of the body. That is kinetics. Okay, and when you consider Azim, sorry, when you consider kinetics, it is involved Newton's second law, which is force equals to mass multiplied by acceleration. Okay, and what is mass? Mass is in m is mass, and then a is acceleration. Okay, all right. So that is kinetics. So kinetics is involve force. Kinematics does not involve force. Okay, do you understand, guys?
Yes, madam.
Yes.
All right. Okay. Now, okay, there are four basic fundamental formula in subject kinematics. Okay, okay, all right. Do you hear some noises at the back? Is it distracting you? Or are you okay? Boleh dengar tak? Suara saya kuat tak? Boleh.
Kuat
Sorry
je.
my mic is not working, my headphone. So of course lah, I have anak yang tengah PDPR tu betul, so dia bunyi bising sikit. Please mind the noise ya. Okay. Alright. Tapi I will try to make my sound very loud Okay. So in dynamics, there are four basic fundamental formulas that are important, which is velocity is time derivative of displacement. This is formula number one. Acceleration is time derivative of velocity. This is formula number two. Force equals to mass multiplied by acceleration, and S equals to R multiplied by theta. Okay, S equals to R multiplied theta is the equation that relates the length of an arc with its centroidal angle. So let's say this is it. This is the S that you want to find. This is theta, and this is R. Okay, excuse me. All right, now, if you notice here, if formula 1 combined with formula 2, you will get a new formula, which is formula number 5. So what I did here is I put dt on the left side, and for equation number 1, I put dt on the left side and I bring velocity on the right side. And for equation number 2, I bring dt on the left-hand side and I bring acceleration on the right-hand side. So in the end, you will get dt equals to ds over v and dv over a. And from this equation here, you will get a new formula, which is ADS equals to VdV. So for kinematics of particles, the three basic equation that you will be using again and again and again and again many times is equation number 1, equation number 2, and equation number 5. Okay, those are the three basic kinematic equation. So it's V equals to time derivative of displacement. Acceleration equals to time derivative of velocity. And then you have AdS equals to VdV. So these are the basic three kinematic equation. Can you remember that? Boleh?
Boleh, madam.
Okay. Do you understand?
Madam,
Okay.
tanya.
Yeah?
Untuk slide madam ni kan, dia bukan yang dari Evans tu kah?
Ni, bukan.
Oh, okay.
Bukan. Okay. Bukan. Lain. Yang daripada Evans tu adalah slide yang daripada buku teks. Okay, you use your own free time to go through that slide, and when you have questions, you can ask me. Okay, boleh?
So this one is from...
This is my own slide. I will give you the slide. Okay,
Okay, madam. Thank you.
boleh? Okay, alright. Okay. Untuk dynamics, we have a standard slide from the textbook buku Beer, and it will be shared for week 1 until week 14. Okay, there will be times that I will use that slide. Okay, there will be times I will use my own slide. Okay, all right. Okay, okay, because many of you don't have the textbook, right? So we prepare a slide from the textbook for you. Okay, and we download it and put it in Evans. Okay, all right. Okay, now. Okay, now if you combine equation 5 and equation 3, you will get a new equation, which is equation 6. And this equation 6 is called principle of work and energy. So if you can see, it is the integration of the F equal multiple ds equals to m integration of the velocity VdV. Okay, that is for work and energy. And if you notice, equation 2 and equation 3, you will get equation number 7. And this equation number 7 is for linear impulse and momentum, if you can see here. Okay, and this one is for work and energy. So if you notice, equation 6 and equation 7 involves what? Involves forces. So it means that this topic is not for topic kinematics. The topic that involves forces is what topic, guys?
Kinetic.
Kinetics. Okay, so if you look at your lesson plan later on in topic kinetics, you will see that they have a subtopic which is work energy and impulse and momentum. Okay, so it means this topic is going to be explained to you later. I just like to introduce to you now because I want to show you that the equation for the next later topic uses the equation from the basic kinematic equation. Okay, so just an example. Let's say one day you are going to do topic that is related on kinetics. Kinetics. This is kinetics, and this is kinetics. Okay, the question does not mention what method that you want to use, but they tell you force is given, time is given, and velocity is given. Okay, which one you want to use? You want to use equation 7 for impulse or momentum, or you want to use equation 6 for work and energy? Which one? I repeat, force is given, time is given, and velocity is given. Which one? Guys, do you understand my question?
7.
Yes, that is correct. Why? Because in equation 7, there is time. Okay, so let's say I repeat the same question, but different variables. Force is given, velocity is given, but they ask you to find displacement.
6.
Yes, that's correct. Okay, now I'm gonna mix it up again now. Force is not given, velocity is given, time is given, but they ask you to find the displacement. I repeat, force is not given. There is no force. There's only velocity and time. But they ask you to find the displacement.
Number 1.
Yes, number 1. Okay, so you understand what I mean right now? So when you get a question, the important key thing is you need to look at what are the variables given to you. And from the variables given to you, you can identify whether this question is kinematics or kinetics, and whether you want to use the basic kinematic equation or you want to use the question that has forces, which is work, energy, or impulse. Okay? Boleh? Okay, but don't worry. Right now, we're going to focus only for topic chapter 1. We're only going to use questions that is in equation 1, 2, and 5 only. Later on, when we go to the next topic, we're going to go into detail equation in topic 6 and 7, but not now. Okay? Boleh? Can I proceed?
Okay, madam.
Okay, all right.
Yes.
Okay, good. Now, so as you notice, what is the lesson outcome for this topic? Basically, if you look back at the lesson plan, the lesson outcome is basically we want to identify the position, which is the displacement, the acceleration, and the velocity of a given particle moving in a straight line. So basically, we can study the motion. So here there is an example, as you can see on the right, there is 2 vehicles here. They are both moving in a straight line. Okay, because this road is straight. Okay, and you can also see a marching band here. They are also moving in a straight line. They are soldiers marching in a parade. So these are examples of a straight line. Okay, so for today's class, kita akan fokus rectilinear motion of a particle. Okay, so what is rectilinear? As I mentioned many times, is the path of the motion in a straight line. Okay, and what are the variables we need? We need the time and we need the distance along the line, x as a function of time. So let's say this is the line in the x as a function of time. And from these variables, we can find the position, we can find the velocity, and we can find the, acceleration. So basically in dynamics, you need to be able to differentiate what is the difference between position, distance, and displacement. What is the difference between speed and velocity? Okay, now, since we are in topic 1, we're going to consider a lot on displacement. So what is displacement? Displacement is the change of position of an object at a given time. It means the object must change position at a given time. Okay, that is displacement. So what is the formula for displacement? So let's say you have an object. Okay, this object here, this ball here. This is the origin. Okay, and then this here, there's a new position. Okay, so what is the displacement? So the displacement is the distance of this, from here to here, which is s prime, minus the distance from here to here, which is s. So the displacement delta s is s prime minus s. So that is the formula for displacement. And the definition of displacement is the change of the position of the object as time changes. Okay, so position is the positive scalar, but displacement is a quantity vector. What it means is a quantity vector, you can have positive and negative value. It means the displacement can be negative also, and it can be positive. Okay, now, all right. Okay, can I continue? Are you okay, guys? How many minutes left do I have for class?
15.
50?
15 minutes.
15 minutes, okay, all right, okay. Now, do you have class after this?
No.
Anyone who has class after this? Ada tak anybody? No, okay. Just in case kita terdrag sikit, are you okay?
Okay, madam.
Okay, all right. Okay, sorry if terdrag sikit Okay. Now, If the particle moves through a displacement delta s during a time interval, the average velocity is delta s divided by delta t. But when delta t is approaching zero, sometimes the average velocity becomes instantaneous velocity. The velocity is time derivative of displacement. Okay, this is the formula 1 yang tadi lah. Okay. Speed is the magnitude of velocity. It has no direction. It is a positive scalar. Speed is the total distance traveled, st, divided by the time taken. Okay, so this is average speed. This is formula for average speed. Okay, so the distance traveled, st, is the actual path traveled and it's not the same with displacement. Please jangan confuse dengan displacement dengan distance travel. Is two different things. Okay, now let's say I give you one example. You see this ball? Okay, this ball is here. It goes to the right for 5 meters and then it returns back to the same position with a distance of 5 meters. So memula dia gerak sini and then dia patah balik sini. Okay, and the time taken is 5 seconds. Okay, for it to travel from right to left. Okay, now what is the distance travel? Can anyone tell me? What is the distance travel? What is the distance travel? Distance travel is the actual path travel. So what is the actual path travel? So what is the distance travel, guys? It's okay if you can. Berapa? What is it?
The path that have that object going to.
Yeah, so tell me the answer.
Answer.
Berapa? What is the answer?
I'm astronaut.
5 meter. Oh,
Alim, close the door. What is the distance travel again?
the 5 meter.
Wrong. Try again.
10 meters.
Yes, because first it went from left to right for 5 meters. And then, sorry, not left to right, it turned right for 5 meters. And then it went back to the same position for 5 meters. So the total distance travel, ST, is 10 meters. Okay, now what is the average speed? Can you calculate for me the average speed?
Five.
How do you get 5?
The distance travel divided by times, which is 5 seconds.
So, dapat 5 ke?
Then 2.
Ah,
Madam.
okay, 2 what? Units, what is the unit?
Meter per second.
Okay. Okay, next. What is the average velocity? What is the average velocity? Can anyone try? What is the average velocity?
2.
1.
Okay.
1.
Someone says 2.
0.
1. Someone says 1. No, someone says 0. Which one do you think is the correct answer? Okay, the correct answer is 0. Who answered 0 just now?
Saya.
Okay, tell me why you pick 0.
Sebab apa? Distance dan displacement dia lain sikit. Dia macam kalau dia patah balik dia akan jadi kosong. Seingat saya lah, saya tak ingat sangat.
Yes, that's correct. Because displacement is what is the definition of displacement? Is the change of position of the object as time changes. But did it change position?
No.
No, it came back to the original position. Okay, good. All right. Okay, now you understand that. So basically, in dynamics, you need to really understand the terms, the definitions, the units, what it means, the topics, everything. By doing that, you can understand better. Okay, now. So what is the average acceleration? Average acceleration is delta V over delta T. And what is the acceleration? Is also the when it's approaching zero, the time is approaching zero, it becomes instantaneous acceleration. So it becomes the time derivative over velocity. Or you can say d squared s over dt. This is for acceleration. So this is the other formula that we use, formula number 2. Okay, all right. So basically, this rocket is moving up at a straight rectilinear line. You can determine using v equals to ds over dt and a equals dv over dt. You can find the velocity and the acceleration. Okay, all right. Okay, now just a little bit more, please hang on. Okay, there is another thing that I want to teach you is rectilinear motion by using constant acceleration. Okay, it has constant acceleration. Okay, okay, so what it means is the acceleration is constant. Example is this boy throwing this ball on the ground. When the boy is throwing this ball on the ground, the acceleration is constant. It is 9.81 meter per second squared. Okay. All right. So when you have question that is rectilinear motion, but with constant acceleration, you need to derive 3 more new equations by using this basic kinematic equation. Okay. Right. So these are 3 basic kinematic equations. Position, velocity, and acceleration are all a function of time. Let's look at a special case where the acceleration is not changing with time, or rectilinear motion has a constant acceleration. So when you get a question that the acceleration is not changing or the acceleration is constant, we will need to derive 3 new equations to solve rectilinear motion with constant acceleration. Okay. So if acceleration is constant, AC is constant, and velocity V naught is initial velocity, and then S naught is the initial position. Okay, we need to use basic 3 kinematic equation. We can integrate and arrange in such a way to get a new equation. So this one is based on equation number 2. Okay. Equation number 2 is acceleration equals to dv over dt. What you need to do is you need to bring dt beside a, so you will get dv equals to a dt. So the acceleration here now has become ac. AC is what? Constant acceleration. So what we need to do is we need to integrate both sides. So when you integrate dv, you will be integrating dv based on velocity, and then you will also be integrating adt based on time. So when you integrate both sides, you'll be left with v minus v naught equals to act, and t initial must be 0 here. So when you integrate with time, it becomes only t. So then you will have a new formula here, is V equals to V naught plus ACT. So this is the new formula. And this new formula is integrated based on this formula. Okay. So this equation lets us calculate what? The velocity of an object at any given time with constant acceleration. Okay, it's okay, just relax. Okay, don't think there's too much formula. It's just using the basic equation. Okay, next is this formula, V equals to ds over dt. This is based on the first equation. Okay, all right. So so what I did is I put dt besides v, so you will get ds equals to ds equals to v dt. So when you integrate both sides, you will integrate both sides here. You will integrate based on position, ds, displacement, and then you also integrate based on time. But the difference is the velocity here, v equals to dt, you replace v with v naught plus act. Okay, so when you replace that, you integrate both sides, you have s equals to s naught equals to v naught t plus 1 over 2 act squared. Okay, then you will get a new formula here. Okay, this is the arrangement of the formula, which is s equals to s naught plus v naught t plus 1 over 2 act squared. So this equation comes from this equation. Okay, so when you integrate equation v equals to ds over dt, you get equation number 8. Okay, so basically what you need to do is you need to identify what are the variables and what are the constants. Okay, now last formula is ads equals to v dv. So you will integrate on the left hand side and you integrate on the right hand side. So when you integrate both sides, you will end up having this final equation. Okay. So the thing you see here on the left is the basic kinematic equation. And then after you have integrated the basic kinematic equation, you have three new equations, but these three new equations are the basic kinematic equations, but with constant acceleration. Okay? Right. So don't worry if you don't memorize it. You can always use mathematical calculation and just integrate it, and you'll get the new equations here. Okay. All right. However, in your case, because you're online, your open book is easy for you. Okay. You can just have your notes on the side and try to answer the questions. Okay. Now. Okay, can we just spend just a few minutes to answer one question? Can we?
Yes, madam.
Yes, madam.
Okay. Okay, can you please copy this question? Sorry, tak nampak. Okay, can you please copy this question? Sorry, copy that question and then we will start to do it together. Boleh?
Boleh.
Okay.
Okay, madam.
Okay, can you hear me, guys?
Yes.
Okay, kejap Ternampak pula solution dia. Kejap. Okay, now, all right. Okay, the car on the left moves in a straight line. So when you see the word straight line, it means it is moving in a rectilinear motion, such that for a short time, its velocity is v equals to 0.6 t squared plus t meter per second, where t is in second. Determine its position and acceleration when t equals to 3 seconds, where t equals to 0, s equals to 0. So what are you given? You are given v equals to 0.6 t squared plus t. They ask you to find the position. They ask you to find the position and they've asked you to find the acceleration. So what is the position? What is the acceleration? And they give you the time. Okay, now, so when you read this question, is this question basic kinematic equation? The normal one, or is this using the basic kinematic equation with constant acceleration? Which one? Which one?
Basic.
Normal.
Okay, this is using the basic kinematic equation, right? Okay,
Yes.
so there's no constant acceleration involved because for constant acceleration is an example when you throw things, right? It has a constant acceleration, and in here it did not mention anything with constant acceleration. So for this question, you're going to use the basic kinematic equation. So what is the formula? Formula number one is V equals to ds over dt. Equation number two is A equals to dv over dt, and then A ds equals to vd. Okay, now, so from these three equations, which equation you want to use to solve the position? Which one you want to use? Have a look. You're given velocity, you're given time. You need to find the position. So which equation? 1, 2, or 3?
1.
Yes, equation number 1. So how do you do this? So ds over dt, you have the answer, which is, you have the value, which is 0.6 t squared plus t. Okay. All right. So what you need to do, you need to integrate both sides. So before that, you put ds equals to 0.6 t squared plus t dt. So you need to integrate both sides. So when you integrate both sides, the initial position is 0. So 0 to s and 0 to t. So when you integrate the displacement, it will become S only. So but S minus 0 is S. So and then when you integrate with time, what do you get?
Sorry, akan tunggu lama.
0.2 T cube plus what? Do you remember
T
your
square.
integration? What? What is it? 0.
T square over 2.
Yes. Okay.
Hmm.
So what you need to do is you need to put t equals to 3 seconds to find s. Can you quickly find what is s? Ada calculator tak? Do you have your calculator with you?
9.9.
Okay. Good. That is correct. Okay, now for the next question, what is the next question? They ask you to find acceleration. Now, which formula you want to use?
2. Sekejap. ADS.
Hello, sorry, my internet terhilang pula tadi. But I'm back. Can you still hear me? Hello?
Yes, madam.
Okay, sorry. Okay,
Yes, betul.
okay. Sikit lagi nak habis dah. Okay, okay. Padahal you all did not answer me when I was asking. Okay, rupanya tak ada internet. Okay, now you need to find the acceleration. Which formula you need to use? You're given the velocity, you're given the time, you need to find the acceleration. Which basic kinematic equation formula you want to use? Equation 1, 2 or 3?
3.
3, okay, but you can also use equation number
2.
2 because it's straightforward. Okay, can you please try use equation number 2 and then get back to me? Give me the answer. Okay, do you get the answer? Tahu tak macam mana nak buat? Hello, can you hear me guys?
Not yet, madam.
Not yet, what happened?
Pasal blur sekejap.
Okay, blur sekejap. Okay, it's okay. Okay, acceleration equals to dv over dt. Do you have the velocity? You have, right? So the velocity here is 0.6 t squared plus t. Okay, all right. So basically what you need to do, if it's d over dt, what do you need to do? Do you need to differentiate or integrate?
Integrate.
Yes, you need to integrate. Huh? What is it? Integrate ke differentiate?
Differentiate.
Differentiate. So when you differentiate, it will be 1 over 2 t plus what? Plus 1. Okay. All right. So then what do? You put t equals to 3 seconds and you can find the acceleration. So the acceleration will be
3.3 meter per second square.
huh?
11.8.
11.
What is the acceleration?
11.8.
Salah.
4.6.
4.6.
Macam mana boleh salah tekan tu?
Silap kuarter 3, madam.
Ayo. Okay. So this is the answer. Okay. So basically what you need to understand is when you get a question, you must identify, okay, the first thing you identify, this is a kinematic equation. and it uses the basic kinematic equation, and it is a rectilinear motion. And then you look at the variables given, and then you identify what is the equation that you want to use to solve the problem. So to find the position, you use equation number 1, and then to find the acceleration, you use equation number 2. However, the way method in solving, for equation number 1, you need to differentiate in order you to get the position. For equation number 2, you need to differentiate in order to get the acceleration. Okay? All right. Okay, guys. Okay. So in your albums, there is a tutorial that has a lot of examples that you can try on rectilinear motion. Why don't you try using your free time? Can you do that?
Yes.
Yes,
Okay, all right. And then in albums, there's also one example on the video that I've uploaded myself, explaining on kinematics of particles. That it uses constant acceleration. Did you see that video? Perasan tak ada video?
Yes.
Yes.
Ada kan? Alright. Have you looked at that video before?
Tengok yang Twitter je, madam.
Ah?
Saya tengok yang Twitter.
Saya cari kat mana?
Saya tengok yang Twitter je.
Saya tak faham. Saya tengok yang Twitter je. Apa maksudnya tu?
Video madam yang tutorial. Yang free
Ah.
fall ke apa dah?
Yes, that one. Ada kan?
Ada?
Okay. Have you seen that video?
Yes.
Have you seen
Yes.
that video? Okay. So that video is also available in YouTube, and I already put it in albums. Okay. And then that video involves with constant acceleration, right? Okay, siapa tu? Iqmal. Boleh tak you share your screen sekejap and show me your opening albums? I takut you all ni tak buka what I'm telling you. Can you please share your screen?
Okay, jap.
You share your screen. I want to make sure what you're doing is correct.
Kejap. Share screen. Lambat Keluar, madam.
Keluar? Okay, cuba you buka albums. Okay, can you open bahagian submission, select the semester. Okay, yes. That video. Okay, are you talking about this video?
Yes.
Okay, cuba you play that video and then pause kejap dekat bahagian tu, play the video.
Allah, internet. Bahagian mana, madam?
Okay. Play. Ni. Okay, a ball was thrown up in the air 1.2 meters above the ground. After 3 seconds, the ball returns to the ground. Determine the maximum height it reached. Okay, when you read this question, number 1, you know that it's rectilinear motion. How do you know it's rectilinear motion?
Bergerak dalam straight.
Okay, it's thrown
One
up in the air
direction.
kan? Okay, and then how do you know you need to use kinematics of particles with constant acceleration formula? How do you know that you have to use that formula? Because here the acceleration is constant. Okay?
Gravity.
Yes, because when when the acceleration is thrown up, when the ball is thrown up in the air, the acceleration is constant. So you need to use
Basic kinematics.
yes. Okay. So for this example, I will not explain in class. I need you to look at the video to understand. Can you do that?
Yes, madam.
Boleh eh?
Yes, madam.
Okay,
Yes.
all right. Okay, so that's all for today's class. I will see you next week. Do you have any question?
No, madam.
No, madam. Semua okay, eh?
Okay.
Okay, all right, good. Can you please fill in the attendance now?
Yes.
So for today's class, you need to fill the attendance for week 1 for tutorial. So just write what you understand about what you learned in today's class. Okay? Alright? Boleh?
Okay, madam.
Okay, alright. So thank you guys. Sorry kita extend extra 50 minutes. Okay, so I stop the class recording and I will share this recorded video. Boleh eh?
Okay.
Okay.